Hello friends, I'm Bob. In this video, I will be showing you the solution to the Maclaurin series of square root 1 plus cosine x up to the x squared terms. Before I do so, if you guys like the solution, help me press the thumbs up icon below this video. The function can be expressed as an infinite series called the Maclaurin series. How do we go about doing so is we use the top right hand corner's equation where a function of x can be expressed as an infinite series in which my f0 is the function evaluated at x equals to 0, f prime 0 is the function differentiated once and evaluated at x equals to 0, f double prime 0 is the function differentiated twice and evaluated at x equals to 0. To start off solving this problem, we will let the function of x be equals to square root of 1 plus cosine x. And we first differentiate the function once and we get the answer, which is half 1 plus cosine x to the power of negative half, and then we differentiate the inside, which is 1 plus cosine x, we get negative sine x. And the next step we will do is we will differentiate the function twice. So in this case, we will use from here the product rule. So how do we go about doing so is that we will first copy half 1 plus cosine x to the power of negative half, and we differentiate with respect to x of negative sine x. And what we do is that we will copy now half times negative sine x, then we differentiate with respect to x of 1 plus cosine x to the power of negative half. We can next evaluate the first term by keeping this as the same, and then we differentiate with respect to x of negative sine x, which is negative cosine x. And as for the second term, we will keep this as it is. Then we evaluate the differentiation with respect to x of 1 plus cosine x to the power of negative half. It's basically just negative half 1 plus cosine x to the power of negative 3 over 2. And then we differentiate 1 plus cosine x, we get negative sine x. Then we simplify the whole equation, we get half 1 plus cosine x to the power of negative half of negative cosine x. Subtracting away, we have half times negative half is 1/4 with a minus sign in front of waiting, and then negative sine x times negative sine x gives me sine square x. Okay, so we then next evaluate what is our f0. That means substituting x equals 0 into fx. My cosine 0 is 1, so we get f0 as square root of 2. F prime 0, basically substituting x equals 0 into f prime x. We know this is 0 because sine 0 is equals to 0, so hence anything times 0 is equal to 0, so we have f prime 0 as 0. Last but not least, we have f double prime 0, substituting x equals 0 into f double prime x. So we look at the first term. The first term, this is negative 1, and cosine x is just 1, right? Because cosine 0 is 1. And hence we have the answer, which is negative half. Whereas for the second term, we have sine square x is just 0, so basically it's just negative half, which is f double prime 0 is just negative half. Finally, we will use the equation on the top right hand corner of the screen to find the Maclaurin series of square root of 1 plus cosine x. The Maclaurin series of square root of 1 plus cosine x can be approximated up to the x squared term. It would be as follows: f0 is square root of 2, f prime 0 is 0, so we don't have the second term here. And then the third term, we have f double prime 0 is negative half divided by 2 factorial x squared. So simplifying this, we have square root of 2 subtracting away 1/4 x squared. This is the final answer of the Maclaurin series of square root of 1 plus cosine x up to x squared term. If you guys like the solution, help me press the thumbs up icon and do consider to subscribe to this channel. My name is Bob. Thank you guys for watching, and I will see you in the next video. Goodbye guys.